Solving polynomial equations, part 2. So our general strategy for solving polynomial equations is this. We want to make one side equal 0. So we move the terms around so that they're all on one side of the equation and one side of the equation is equal to 0. And then we arrange that other side so that it can be factored, and we factor, and then once we have our factored form of the polynomial equation with all on one side and the other side being 0, we solve with the zero product property. So let's go ahead and look at an example. So first of all, note that this is not a quadratic equation, but that doesn't mean that we can't still solve it. So I'm going to go ahead and move each of these two terms over to the left-hand side of the equation. With subtraction, so that now I have one side of my equation equal to 0. And then I'm going to look at this equation and see if I can factor it. And sure enough, yeah, I can. I can take off a 3x. That would leave me with x squared minus 4x minus 21. And now you see that I've got 3x here and a simple trinomial inside the brackets. So I can factor that simple trinomial, two numbers that multiply to negative 21 and get me 4. I'm going to try 7 and 3. And if I use negative 7 plus 3, that'll work for me. So I have x minus 7 and x plus 3. And all that's equal to 0. Well, now instead of having two factors, I have 3 factors. 1, 2, 3. So either 3x equals 0, which implies that x equals 0, or x minus 7 equals 0, which implies that x equals 7, or I could have x plus 3 equals 0, which would mean x equals negative 3. So those are my 3 solutions to this equation. X equals 0, 7, or negative 3. Often, and what's conventional is that you list them from most negative to most positive, like a number line. So that's probably the best way you could write your solution if you were concerned with that. So we can also apply what we've learned to solve word problems using our polynomial equations. So we're told the product, that means multiply, of two consecutive odd integers is 323. So 2 consecutive odd integers. What are the 2 integers? And so when we do this, we have to pick variables for what we're trying to find. So if the first number, I'm just going to call it x, because it's a number we want to find. So that's an odd integer. So let's say x is our first one. Well, what's our next one? Well, it can't be x plus 1, because that would be an even number. So it has to be x plus 2. So the second number, if x is an odd integer, the second odd, or the consecutive or next odd integer would be x plus 2. Well, I can use those to write this equation. The product of these two numbers, x times x plus 2, is 323. What are the 2 integers? Well, let's go ahead and solve this equation. So first of all, I need one side to be equal to 0. So I'm going to multiply this side on the left so that I can move the negative 323 over to the other side. And now I can factor. And it's a simple trinomial with an enormous number. So I'm going to use my calculator. And I'm just going to see what can 323 be divided by. It's got to be something. After a bunch of searching that I just did in my calculator, and I didn't want to make you sit through it, I figured out that negative 323 can be divided by 17. And the other number is 19. So 17 times 19 is equal to 323. And we need these one to be negative and one to be positive, so that when we add them together we get plus 2. And that means that x minus 17 is equal to, times x plus 19 is equal to 0. So I have 2 solutions to this equation. Either x minus 17 is equal to 0, which means x equals 17, or x plus 19 is equal to 0, which means x equals negative 19. So, have we answered the question? And the answer is no. We need the solution, we need to answer the question, which means what are the two integers, the two consecutive odd integers? Well, if x is the first one, the second one, that's the first, the second is x plus 2, which would mean the second number is 19. So the two consecutive odd integers are 17 and 19. But there's also a solution here, which is that x could be negative 19, which would mean the second number, x plus 2, is negative 17. So negative 19 and negative 17 also solve this question. Those are both consecutive odd numbers that solve this problem. Geometry examples are also common problems that can be solved with polynomial equations. So here's an example. A rectangular bedroom has an area of 117 square feet. So we're being told something. Area is 117 square feet. And we're also being told that it's rectangular. So think in your head about this formula. Area of a rectangle is length times width. So now let's see what we have in this problem. The length of the bedroom is 4 feet longer than the width. What are the dimensions of the room? So, what's the width equal to? I don't know, but I'm just going to call it W because I know that the length is 4 feet longer than that. So rather than call it L, I'm just going to call it W plus 4. So what that means is that if the area is equal to length times width, well, we know that the area is 117, and we know that the length is 4 feet longer than the width. So here I have a polynomial equation that I can solve. And it's similar to the last one in that I have to make one side equal 0. So I'm going to multiply the w into the brackets, get w squared plus 4w, take away the 117, and I have my polynomial equation. Now to solve this, again, I need to find factors of 117. These numbers are not a ton of fun to work with, but just be patient. Try a few numbers in your calculator and we will find them. So I actually just got really lucky with my first guess. I did 117 divided by 9, and I got 13. So 9 times 13 is equal to 117, and if I do plus 13 minus 9, I get the negative 117 that I want and the plus 4. So that means the solution to this equation is w minus 9 and w plus 13. So either the width minus 9 is equal to 0, or the width plus 13 is equal to 0. So the width is either 9 feet, or the width is equal to negative 13 feet. Well, what do we think about those two solutions? I do not like one of them, because when we're talking rectangles, width and length, these are measurable numbers. They are real life numbers. So it doesn't make sense to have a negative width. You would just never describe something as being negative 13 feet wide. So I am rejecting one of our two solutions. It is mathematically a good solution to the equation, but it is not in reality a good solution to the problem. So we're rejecting that one solution, which means that the width, I always like to work left to right, so I'm sorry that I have to go over the left-hand side of the screen here, but the width is equal to 9 feet, and the length is equal to 9 plus 4 is 13 feet. That is my answer to this problem. Ordinarily, I'd usually try to write this below my answer or to the right, because I always think it's good to work down the page or left to right, or some combination of that. But anyway, I'm running out of room on my screen, so that's how I'll write my answer.